All right, dual credit. I'm going to go over a few things as far as your lab goes. We wrote down these equations yesterday, and I left for you the pre-lab. That is your job to work through and try to figure out what is our overall equation that we're trying to produce from these reactions we're working with. All right. We talked about the objective. We also talked about how the coffee cup the heat exchange in the coffee cup is negligible, and so we don't really worry about it. We won't worry about calculating with it. Okay, you've done your procedures. The first procedure we did was 100 milliliters of water and 2 grams of sodium hydroxide. And then procedure 2 was you took 100 milliliters of 0.5 molar hydrochloric acid and 2 grams of sodium hydroxide. And then the third reaction was 50 milliliters of 1.0 mole HCl and 1.0 mole NaOH. So now we're going to get down to the processing the data. Okay, so the idea is on the hydrochloric acid and with the sodium hydroxide and with water, we are treating it as if it has density of basically 1.00. And that has to do with how much I dissolved in there. So if I've measured out 100 milliliters of the substance, then I have 100 grams of that substance because the density of it is approximately 1. So then question number 2 asks you to do a temperature change. Delta T is always going to be T final minus T initial. So it's going to be, since all these are exothermic reactions, it's going to be our high number minus our low number. So I just have a sample data here from a group, and we're taking their 22.3 minus 18.6, and it gives me 3.7 degrees Celsius. So my formula that I'm using is Q equals MC delta T. And again, we're just basically going off the idea that whatever energy the water or the liquid has absorbed, that is how much energy the sodium hydroxide took in order to break its bonds. And that's the idea. So my mass for my water, since it was 100 milliliters, it's 100 grams. The C for water is 4.18 joules per gram degrees Celsius. And my change in temperature was 3.7 from above. So when I take 100 times 4.18 times 3.7, I get 1546.6 joules. Now, notice the question says, convert the joules to kilojoules. And so all I got to do is I got to divide by 1,000, because 1,000 joules equals 1 kilojoule. Okay, so then step 4 says, hey, your delta H equals a negative Q. So my delta H will be a negative 1.5466. because that's in kilojoules. Question number 5 says, calculate the moles of sodium hydroxide used in each reaction. In reaction 1 and 2, this can be found from the mass of the sodium hydroxide. So it's a simple, do your stoichiometry, going from 2 grams to the moles. There are 40 grams in sodium hydroxide, and I do that conversion. And as far as reaction number 3, I have to use the molarity. Now, one of the things we have to do is we've got to convert initially my milliliters of the substance that I used, and I did not do that. So I have 50, so this is going to be wrong. I'm going to go ahead and try to correct it here. I have 50 milliliters of the 0.5. Okay, so I have 50 milliliters of 0.5. No, I don't. This is 1 molar. That's right. So I have 50 milliliters of the 1 molar HCl. Okay. So there are 1,000 milliliters in 1 liter, and so I just need to divide that, or move my decimal. I need to do that conversion first. So I have that, and I get 0 point. I know what I was doing. Okay. It's my original number. All right, there we go, -2. So sorry for that. And then the idea is that N equals C times V. C is your concentration, V is your volume. So my volume is now 5 e to the -2 liters. My molarity was 1 mole, so I just do that number times that, and that gives me my N. So that's how you get that. And this number will now be to the -2. And this unit is moles. Because remember that M equals moles per liter. And so you're going to cross out your liters when you do V times C. Okay, so that's taken care of. And then 6, we're going to use our results from step 4 and 5. We're going to take step 4 divided by 5. And again, this number's changed. And we're going to get, and that should be kilojoules. Our kilojoules per mole. Step number 7 says to verify the results of the experiment, combine the heat of reaction delta H for reaction number 1 and 3. And by the way, that's your hint for your pre-lab. We're putting 1 and 3 together to produce number 2. The sum should be similar to the heat of reaction of delta H per mole for reaction number 2, using the value in reaction 2 as the accepted value and the sum of reactions 1 and 3 as experimental value. Find the percent error. So you got a lot going on here. You got to find your delta H's first for each of the reactions, and then sum them up for 1 and 3, and then do your percent error. And then don't forget your post-lab. Okay. As far as your data collections over here, this was just to help you kind of like organize your thoughts over here. So hopefully that helped. And I do want to see this filled in so I know what your data looks like. Do make sure to show me the math on there. Everybody needs to practice the math because these are important skills. And that is our lab.